Hello, my name is Yusuf Madi and I'm 16 years of age, and the concept that I would like to be presenting today is radioactive decay rates slightly increasing in the conditions of microgravity. So essentially the rationale for this proposal stems from what Newton alluded to and what Henry Cavendish essentially proved, which brings us to the equation force of gravity equals universal gravitational constant multiplied by the product of two masses in a system divided by the distance squared however you're defining the system. It's all dependent. So let's say I'm defining my system between Earth and an isotope, a radioactive isotope, an atom undergoing radioactive decay in the ISS in this case. So essentially, you will have a much lessened effect of gravity due to the distance in which you retain to Earth in this scenario. So with a much reduced effect of gravity, a fundamental force in the universe, but essentially still one of the weakest, what I'm predicting is that you're going to be doing what I like to call removing the middleman in the process of radioactive decay. So that an atom, hopefully in an insulated area in the ISS, would have its eternal atomic forces, which are usually much stronger than gravity itself, having a greater influence, or without any middleman, on the atom, and thus I'm predicting, because of this greater influence of these two much stronger fundamental forces working in the atom, I'm predicting a swing effect. And the swing effect essentially is saying that, let's say person A represents mass or gravity on a system, or mass and gravity on the atom, and the swing's the atom. So let's say person A is swinging at a constant, and they're exerting at a constant energy, so they're going to reach a certain elevation forward and backward. So let's say person A's mother and father are calling them, and they leave, and as soon as they are leaving, they're going to notice that if they exert a slight, when they leave, that the swing will incrementally elevate higher than it would so normally under the added pressure, or in this case, gravity of the person or of the Earth, and thus, in the case in which I'm presenting, this is an analogy to the radioactive decay rate / elevation of the atom distanced from the Earth itself, so thus a reduced effect of gravity. So thus, specifically, let's say for beta radiation, for whatever type of atom, hopefully one that could correspond well to the nature of the experiment, you're going to have a greater, neutrons turning into protons much faster than they would so normally on Earth conditions, and electrons ejecting much faster than they would so normally, once again, on Earth-like conditions. And thus, the way to test for this, or the way I'm proposing to test for this, is via spectroscopy, where you, once again, as mentioned, insulated area in the ISS, you have a spectroscope and you get to observe the fingerprint develop much faster, or slightly faster than you would comparatively on gravity or in Earth-like conditions, thus proving the hypothesis to a certain degree. And the spectral shifts would occur slightly, if it is valid to any degree, slightly more so swift than it would on Earth conditions. And that wraps up my proposal. Thank you for